My name is Anastasia Kazakova. I'm from JetBrains. But today I'm not going to talk about our tools. So if you're interested, just come to our booth on Wednesday and Thursday. I'm going to talk about the new standards. And before I start, I would like to say a little bit sorry for my voice. I'm a little bit running out of it, but I'll try to make this work for this 1 hour. So talking about myself for quite a bit, I was working as a C++ developer for 8 years, doing some networking and embedded stuff. And then I moved to JetBrains, working mostly as product marketing manager, do some evangelism around the tools. And I'm also running my own C++ user group in St. Petersburg in Russia. So this talk is mostly about the triangle between like developers, languages, and tools, and how they are connected and related. So if we start thinking, so we have a developer who's actually started working on some task in a particular area, and he starts with selecting a proper language. I'm a type of the person who believes there are no universal languages, and so if he selects C++, then he has some reasons for that and some special area for that. So language features, they are to help developers to write some accurate and concise code to solve their particular problems for the area they are working in, and to provide some necessary performance and actually fit into their business environment, the whole infrastructure they have. So if we come with the tools, actually developers, they need tools to leverage some language issues, to make developers more productive with some routine tasks, and also to push some guidelines, like the CppCon core guidelines that Björn is talking about, and any type of guidelines you have. So they're just impossible without the tools, because you will completely forget about all the guidelines when you have a project with a deadline back yesterday and like 50 people working on a project and whatever is also anyway is happening in your project. So language, they need tools for pushing these kind of guidelines and good practices, and actually for wide adoption of the new language features, because like if the tool is throwing it into your face, like how to modernize your code, you're more likely using modern language features than just without that. But how about the other side? How the language can help tools do better? Can tools benefit from the new language features, or are there any issues with that? So how this relationship evolves. This is what we're going to talk here about, this kind of relationship. So before that, let's see how our C++ reality actually looks like, and how we cope and how we live in all this stuff. So talking about the IDE expectation, when I ask people what they expect from the IDE, usually they start the word correctness, like we expect 100% correctness from the tool so that you can cope with any C++ we write and you're perfect with that. That's good. But then they come with the performance. So they want it to work quickly on the fly, and then they think about some kind of a smartness, so they would like to have some fancy highlighting or a cool completion that is working like immediately. They also want the tool to know about the whole project, like to refactor the whole project, not one translation unit, or do whatever stuff they need, so to find usages across the whole project. And they want it to be helpful. That means that IDE actually has to cope with the incorrect code. So the level of the errors that the IDE can cope differs from compiler completely. So the compiler just stops. The IDE couldn't stop. It has to deal further. And the people actually, they are expecting all the tools that are just exist in the world to be built into their IDE. Some of the tools, they work with the AST, some not. But any kind of tools like that you have on board, believe me or not, the people will be blaming the IDE if the tools are not working. That's just our reality. But okay, let's just leave the whole list. Let's just take the first two, correctness and performance. And actually, for C++ especially, this is some kind of a balance question. So you have to provide the correct tool, but still you have to be quick. And each time with each problem, you have to think about this balance. And I'll come back to this balance in a couple of slides back, and you'll see why. So as I said, IDE works with any code. So it could be legacy code that is back in many years, and it's quite old, and like no one writes the code that way And it could be modern standards, and the people are actually asking for new features before they even arrive to the kind of C++ standard or even technical specification. They just come in and say, hey, I need this feature right now. And sometimes these things coexist, so they have some legacy project and they want to use some new features. And think about the incorrect code that I already mentioned, like the error recovery level that is completely different from what we have in the compilers. In the beginning of this year, we made a big research on C++ developers, not only our users. It was quite extensive, so in total we got 9,000 responses. And here we have two graphs. The big one is which standard the people are using, so that's not exclusive, so the total is bigger than 100. Don't be surprised. And this round one is if you're going to move to a new standard. And you see like half of the respondents are not going to move to a new standard at all. And you see that the biggest part is actually using C++ 11. But there are quite a big part of people who are actually going to move to C++ 17. That's huge. That's really great. But that shows the difference. That shows the variety. So there is no like something on a trend. So the people select different things. And I would like to play some kind of a game here with you. So I call it Are They Different? So I will be actually showing you some pieces of code with very similar lines. And you have to decide if these lines are different or not. So here's the first example. And there are actually two lines in the end of the test function, one with K and one with L. They look very similar, but the question is, are they different? I will give you some seconds to think. Hey, I see people smiling. Yeah, so actually they are different. So one is template and one is binary expression. Okay, let's play another round. Are these lines different? And actually the answer is yes again. So the first one is the constructor with parameter x, and the second is a variable z with type x. Okay, another example. Another two lines in the end of the test function, and again the same question. Are they different? Yeah, I hope you got it. So yes, they are different as well. And so the first one is a cast, and the second one is an expression. And the last example for this game is actually this one. Two lines. Very similar in the beginning. They have just a difference in the end. And are these lines different? And actually the answer is also yes, because first one is the list of declarations and the second one is the list of expressions. And you know what's interesting? To get it, we have to read the line until the very end. And this could be some kind of an infinite input. And now think about the language tool you're working with. So you have an IDE that has to deal somehow with your code, and it has to make the difference in this kind of situation, to make the highlighting different, to make the code formatting different, to provide some different IntelliSense for you. And in each place of this, like some code like this, it has to distinguish types from non-types. And that's the magic question for C++ and for language tools working with C++. That's actually the biggest challenge. So we have to distinguish types from non-types, and we need it everywhere. And to do that, we actually need to parse and resolve the code, because without that, that's impossible. Let's think about what affects the resolve. So there are some simple things like what are the definitions? They're just simple. Default arguments. So you have to check all the signatures to see what are the default arguments and if it fits or not your case. And of course the overload resolution. All the things are in general quite easy, but still the language tool has to deal with that, has to do that, has to understand all this code, and actually this code could be spread around the whole your project, so it should not be just one file. Okay, so the language tool has to parse and resolve the code. What does it need it for? Actually, for everything. So not just for some smart refactoring, a code highlighting, but for the simple things like just format your code properly or highlight your code properly. And there is a very easy thing like highlighting. Could we highlight with the Luxor in C++? Like this code could not be compiled properly with all C++ version because it required a space between the last two angles in the this line. And this is all about the C++. Like in C++ 11, there is a description in the standard how you should deal with that, and you can live without a space now, and because the parser will just get if it's a template or not, and there is a rule actually doing an actual resolve inside the standard description. And to be honest, that's the only language I know that has these big problems coming out of their very actually simple examples. Another example about highlighting with the Luxor, very simple, could I highlight just keywords with the Luxor? And the answer again is not. Because here, if I highlight public, that won't be correct. Because I have a macro, and actually this is a variable called public here. So it's not correct just to use the Luxor for highlighting. So, how we deal? Actually, there is some kind of a game of parsers happening in all language tools, in all IDEs. So there are different ways. Tools, they have heuristics, they have some fuzzy parsers, they have using several parsers at a time, and they are trying to be based on Clang and whatever ways. So there are many things happening. So IDEs learn to be smart with C++, and to find some kind of a balance between, again, correctness and performance. For example, if we take the Clang format tool, it's a very nice and quick tool for formatting, but do you know that it's not using a complete parser? It's using some kind of a fuzzy parser, so it's not looking into the header files, it's not parsing the code properly, just because it's for another task. It's for quickly formatting your code, but it could be confused in case of C++ because things happen. IDEs, they are doing a lot of stuff here, so I'm not going to talk very detailed about these ways, but there are a lot of things happening in the way of optimizing the parser, so it's different from the typical parser that the compiler is actually using. The compiler usually resolves the name immediately when it meets it. IDE could sometimes postpone, and it really helps, to save the time, to increase the performance. IDEs, they like the global includes because these are some kind of the same header files included into each translation unit, so they can cache, and that's good until you write some kind of a define before you global include. Local reparse is also a good thing when you could save on performance, because you could, for example, skip the whole function body and just parse the function signature until you use the auto return type, because in that case you have to parse the function body to understand actually what's going back from this function, what's returned back. So there are many tricky ways, and with that understanding, let's now look at the actual features that are coming from the new standards. This is some kind of list that I'm gonna work through for now. Let's start with if context for that we already have. So this is the example that is solving a pretty easy task, like get value depending on either its pointer or not. And here is the implementation using enable if. That's quite nice and maybe something first coming into our mind, but now let's look from the point of a tool. If we manage to find get value call somewhere and we try to find out what is that actually, we have to look and compare what is actually there. Is it the first or is it the second one? So we have to calculate this enable if, and we have to understand what exactly is the function. Is there a better way? Actually, it is. So I could rewrite this nice function with if const expr and just hide everything inside. And that's actually a good thing because I'm hiding the implementation details actually inside the function. And now the IDE has just one function. It has auto return type, which I said is not very nice, but still, it's one function. So if you just find usages, you just go and look for all of them, and you just don't mind what's inside until you really have to. Okay, this is about if const expr. Now let's talk about the concept. Actually, concept is a very good thing from the point of a language tool to some extent, because it's like a template with a proper interface. Because what is template from the language tool? It's just a text. It has nothing before it was used. So to understand what's there in the template, the language tool, the IDE, has to find the usages, has to understand how the template is instantiated, how it's used. But if we have a concept, then we could make some decisions based on this concept. We could cache some information, and later we could check if it's fitting the concept or not with this kind of cache information. And we could even do more. We could suggest some completion. For example, if the concept is saying that there is some kind of function existing there, so we could, for example, complete it. We could make some checks. We could provide some additional information about this text. And so while you're writing this template, you could benefit from some intelligence that is better than just simple text. And actually, talking about the cache, when I said that we could try and cache some information, that means that we could do some performance improvements on the stage of checking if something complies this concept. Okay, now includes. What is includes in C++? Just a text includes, text substitution. That's really bad. If you look at this example on the right of the slide, and you just get that this line with X from the example from the game, it actually has different meaning depending on what magic is, because it's different. It's either type or X is just an integer, and it depends on this magic. And so if you have this header file, you parse it, you get all information. To understand what's really in your code, you have to find out what this magic is, and if someone is changing it, you have to parse the whole thing and change all the information in your code. And this is just insane for the tools. So when you have lots of header files built like that, don't be surprised that you see that your tool is just going mad, because it's trying to reparse the thing all the time. You see that the problem here is that actually the information is affected by this kind of context, and it takes most of the time for the language tool to understand what's inside, to parse, to take information from these header files. And these headers, they could be included in different translation units with different contexts, and then you have to store all the information again and again with using this context. And the one story is that one that's global include, and another story is completely when this is kind of a local include somewhere inside your C++ function, somewhere in the beginning or somewhere in the middle. So this, there are also ill-formed includes that makes the whole story even worse. What is better? Modelless, of course, because this is the thing very similar to what we, for example, have in Java. We have imports with a very clear interface defined. And if we know what's inside, that's actually great, because we could guess that there should be these kind of functions, and we could complete them, and we could say no if you're making a mistake in a function. We could highlight in red and say no, it's not from this model. So, and models are hopefully are less context dependent. And if we think about STD2, like when Alasdair was talking about STD2 at C++ Now, I was very glad to hear that he was talking about this kind of direction with concept and models in STD2. Because what, for example, we do in our tools for STD library for now, we do some hacks. We try to guess what's inside this standard library for this architecture, cache this information, and use it. But that's not legal because that's just text include. But if it's a model, these hacks become more official. So we can do it like in a true and natural way. And this actually optimizes the work and make your actually work with the code easier, because like you have your IDE helping you and not struggling with your text includes. Now let's talk a little bit about contracts. I won't be talking about them a lot, but I would like just to show the possibility that it could be bringing to the language tools. Because like what the contracts are, they're just the runtime checks. But what if your tool could check them before you run the application? That's actually possible. You just need to do the data flow analysis and to include these conditions into this analysis. And hopefully they could be checked to some extent. Like that's doable. So we do data flow analysis in C-lines. And we know that actually some of these conditions could be checked as well. So the contracts, if you think about them like just the runtime conditions, that's good, but maybe we could do more. Now let's talk about reflection. There are actually two parts of reflection: introspection and code generation. If we take the introspection, it's just the ability to inspect a type and retrieve various qualities from the type. So you might want to introspect like object data, members, some member functions, some inheritance, hierarchy, whatever. And the good thing is that tools, language tools, since they parse the code, they have all the information for your introspection. So they can provide it to you, so that's just not an issue. And it could be quick, and that's actually good. But if we talk about reflection, we should talk also about the code generation. And generation code it's actually a big and huge opportunity that you could get into your code. And like I will switch to this slide with meta classes talking about code generation and reflection, because meta classes are actually a great thing from the developer point of view. It helps us to avoid boilerplate code, and this Herb's proposal actually is intended to help us to follow some constraints, to get some DSL without an actual, without another compiler different from C++ compiler. But for the language tool, it means that it has to generate all this code. So this is the example from Herb's proposal. That's very simple. So you just write this small shape code in the top right corner, and you have this kind of meta classes interface definition somewhere, hopefully in some standard library for meta classes. And you just get this kind of shape with some information generated out of it. And it could be much more, so you could generate a long list of functions and the other stuff there. But the thing is that from the point of view of the language tool, you have to generate this code and you can't postpone it, because you'll start using this kind of a shape struct, like this kind of a shape interface over there. And you'll need all these functions to be completed. You'll have your IDE to check these constraints that you have only these functions and don't have any other functions. So this is something that we can't postpone and we have to do. And this is some kind of C++ interpreter that's happening inside your language tool. There could be like some ways to cheat. So we could just allow everything and say do whatever you want until you compile it. or we could just treat everything as text, but that's not a good way because it doesn't help you in any way. The better way is indeed to check these kind of conditions and to parse all these definitions. And probably if we parse the meta class definitions, we could even provide some IntelliSense inside these meta classes definitions. So not to treat them as text, like not to treat this piece on the left just as text, but to provide some highlighting and completion there. That would be awesome. But that needs all this code to be parsed, and that's really tough. Like, that's the story about the reflection code generation and meta classes. And also I would like to talk here about the modernized tools. So we have them coming more or less. So we have the C++ core guidelines. We have support, like native support for core guidelines in Visual Studio, and some guidelines supported in Develop tool, and the Clang Tidy. That's a very powerful Clang family-based tool that provides a lot of modernized features. And it's actually helping to transform your code into a more modern way. So, and I just want to run and to show for those who never saw how the Clang Tidy works, just a small example of integration that we have for the Clang Tidy. And that just running the whole Clang Tidy bunch of stuff with some modernized checks on the code. So it actually finds the issues and fix it, so you can just run it with -fix option and it will update your code. And that means that it could bring your code from the old legacy stage to the more modern code that is maybe easier and for your language tool, and the language tool can help better with it. So if you would like to see more about the tools, I will actually be doing another talk about the tools tomorrow. So showing you lots of bunch of that stuff. But for now, I get, actually that's it. I guess it was quite quick, but still there are some useful references here. If you're interested in some more details of what I was talking here. Actually, the last one is exactly about some optimization happening in the language tools in comparison to compiler. The talk on LLVM meeting was quite short, but there is a slide from the long talk that was happening at my user group. So, and now we have lots of time for questions, so I'm ready to answer whatever you have. Yeah.
Where can we get a copy of the slides?
Sorry?
Where can we get a copy of the slides?
I guess they will be published somewhere. At least the organizers asked to store the slides.
Videos on YouTube.
Yeah, so I guess somewhere under the YouTube video will be some links, so I guess you'll find the slides. More questions?
Is there any changes that you would like to see coming forward that aren't really in the template?
Sorry. Everything I was talking here is the change that we would like to see to some extent. Like maybe the meta class is not our biggest fan. From the developer point, they are very interesting. From the point of language tool, they're tough. But anyway, all the stuff about models and concepts seems very interesting and provide very interesting abilities, very interesting features that could be built upon these language features in the language tools. And that's really great, there are new horizons coming. Yeah?
So the IDE has to deal with code that is incomplete,
Yeah.
but still provides meaningful results.
Yeah.
So how does all this kind of tie into that? All these fancy new features. How do you?
Yeah, we always have to deal with incomplete code. It doesn't matter if you have all language features or C++ 17. But that's the usual thing. So we have to deal somehow. We have to store some things for some time, to wait until you finish some constructs, just not to spoil everything on your screen. But that's the like typical thing. We try to deal with that, so at least maybe not like, you know, blow off your code until you type the end of the statement. But that's the typical rule, so you got to it quite quickly. So no rocket science actually there. Just the thing that you have to keep in mind always when you are like implementing this kind of stuff. Okay, more questions? Okay, you can come later to me or to the booth and I can answer more if you have some more questions in mind. Thank you.